Hi, we're Group KKED. I'm Kurt.
I'm Evelyn. I'm Kenny.
And today we're going to be performing the pulley experiment. Okay. So for this experiment, at least for the first part of the experiment, we're only going to be using this single pulley, right? We come to the pulley, there's a wheel, we have our strings which apply the tension, right? And then rigged to either side of the pulley, we have a 20-gram weight, which will be our mass 2. And then on the other side of the pulley, we have a 50-gram weight, and this will act as our mass 1. Other than that, there's a sensor in between here. That's how we can calculate the velocity, and then that's how we can calculate the experimental acceleration. Let's get into this experiment. Okay, so when it comes to the experiment itself, right, we understand that there are weights on either side of the pulleys. It's important that we have the mass 1, or the heavier one, be the one that's closer up, right, or towards the actual wheel itself, so that when we let go, it's the one that's going to drag our mass 2. It's important also that there's someone down here to catch the weight when it falls. Otherwise, the weights are going to fall and go up.
So now that we have our software, we're going to make sure that our hardware is connected to the software. And now, like we usually do, we're going to drag the graph. And then put it in velocity. And now we can start our experiment. So now that we have our graph prepared, we're going to start with experiment 1. Now that we have the graph, we'll be getting the time, the acceleration, and then we click another point, and will give us the time and acceleration to combine both points together. So now with our double pulley, we're gonna do 2 clicks. And so now we can get our second acceleration.
Alright, so for the first set of calculations when it comes to the single pulley, first we need to assign our mass 1 and our mass 2. We're going to assign our mass 1 to 55 grams and our mass 2 to 35 grams. And the first thing we need to find is our theoretical acceleration. To find our theoretical acceleration, right, our theoretical acceleration, we know that it's going to be our mass 1 minus our mass 2. Divide that by our mass 1 plus our mass 2. And then finally multiply this by gravity. Gravity being 9.8. So if we go ahead and just plug in the numbers and compute, right? So we're going to have 55 minus 35, and then 55 plus 35 times 9.8. We get that our theoretical acceleration should be somewhere around 2.17 meters per second squared. Now that we just finished finding our theoretical acceleration, we go ahead and perform the experiment, and we can now calculate the experimental acceleration and then compare the theoretical to the experimental to find our percent error. To find our actual experimental acceleration, we know that it's just going to be our second velocity minus our original velocity, all that divided by our second time minus our first time, right? And if we plug in these values, we should get 1.52 minus 1.01, and then divide that by 0.722, subtract out 0.463. When we plug and chug this into the calculator, we get that our experimental acceleration should be 1.97 meters per second squared. And as far as the percent error goes, right, we know that percent error should be our theoretical minus our experimental divided by our theoretical, and then multiply this whole thing by 100. And if we plug that in, 2.17 minus 1.97, all divided by 2.17 once more, we get that our our percent error is roughly about 9.5%. Okay, for the second part of the experiment, now we're going to be working with the double pulley system. As you can see, in the double pulley system, we have two wheels, right? And so using these two wheels, we can actually carry more mass, right? Now, instead, we have 50 grams as our mass 2, and then we have 155 grams as our mass 1. We're going to perform the experiment now, and let's see how it goes.
So now we're gonna perform our second experiment.
Don't let that happen in your experiment.
Okay, so now that we've performed the single pulley experiment, we're going to go ahead and perform our double pulley experiment. And in this case, now we need to assign two different M1 and M2 values. We need to make sure that when we're assigning these values, that our M1 minus 2 times our M2 has to be greater than or equal to the absolute value of 50, right? And so we choose two masses that will satisfy this equation, and in this case we chose 155 grams and 55. And so we're now going to go ahead and find the theoretical acceleration of these pulleys, right? And the theoretical acceleration goes 2 times our mass 2. We're going to subtract out our mass 1. And more specifically, there's a negative in front of this actually. And then divide it all by 1/2 our mass 1 plus 2 times our mass 2. And then finally multiply this whole portion by gravity. Let's go ahead and just start plugging everything in. So again, we should have negative, and then parentheses 2, multiply our 55, subtract out our 155, close it off. Then we're going to divide that by 1/2 times 155 plus 2 times our 55. Close that out. Finally multiply by 9.8. And we get that our theoretical acceleration for the double pulley should be 2.352 meters per second squared. Finally, for the last set of values, we need to calculate the experimental acceleration for the two pulley set, and then the percent error comparing our theoretical to our experimental, right? And so similarly to how we found our other experimental acceleration, we find that it is again our V2 minus our V1 divided by our T2 minus T1. When we plug in these values that we got from our actual experiment, and then divide out our 1.066 minus 0.662. We compute this and we get that our experimental acceleration should be 2.37 meters per second squared. Just like how we did earlier, we're going to go ahead and use our theoretical minus experimental divided by theoretical all multiplied by 100. We plug and check these values. 2.352, subtract out our 2.37, divide that by 2.352 once more, then multiply by 100 as a whole, and we get that our percent error is an astonishing 0.7%.
Okay, so for today's experiment, was our percent error greater or smaller, and why?
Our percentage was smaller because we're getting better at our experiment and our calculations. Between today's two setups, which have a more significant percent error.
So between the two setups of the single pulley and the double pulley, the single pulley had a little bit more percent error, being the 9.5, whereas compared to the double pulley, that was almost swapping less than 1%. I think the reason that is because when we have double pulleys in place, we can actually control the weight a little bit better as it's gliding down, and the sensor picks it up better.
So what other factors besides friction could contribute to our percent error?
It could be the human error, or maybe put in the string wrong, moving it from here to here, or even this one could be right here. Even if we don't hold this right, it could affect the graph.